So let's go ahead and take a look at the first example here. They're asking us to tell which property is represented, and again, your choices are what you saw on the first page. And the question says 2 times 6 in parentheses times 1 is equivalent to 2 times in parentheses 6 times 1. Well, if you remember back from me reading through the definitions, we talked about how the associative property really has to do with taking and moving parentheses around. And as you can see, that's exactly what they did here. The numbers are in the same order, no question, but the parentheses have moved from the front of the problem to the back of the problem. So that's the associative property. Now, of course, the second part of the answer there, fairly obvious. If it's an addition question, you would say that this is the associative property of addition. Obviously, this is not an addition problem, this is a multiplication problem. Since this is a multiplication problem, you're going to tell me it's the associative property of multiplication. And that's all you need to say here for example 1, part A. If we take a look at the B question, it says that 3 plus 0 equals 3. Now, notice that the left and the right side do not say the same thing here. This is actually a problem that's been solved. But what they're showing us here is that if I add 0 to a number, the result is still what I started with. And that's a good descriptor of the identity property as we defined it. I added 0, it didn't change anything, I got exactly what I started with. Obviously, this is the identity property of addition because this is an addition problem. In the C example, they've got 7 plus 9 being the same as 9 plus 7. Well, notice in this one, they've changed the order of the numbers. And when we change the order of the numbers, that's always indicative of the commutative property as we defined it. Remember, the commutative property says I can change the order of the numbers around and still get the same result. And indeed, 7 plus 9 would be the same as 9 plus 7, so that is an example of the commutative property of addition, of course, because this is an addition problem. Okay, so let's go ahead and take a look now at example 2. In example 2, they're asking us to simplify the expression and justify the step. Now, when they're asking us to justify the step, really what they're asking us to do is use one of those 4 properties and use it in a way to make the problem simpler, or to say what they're doing. So, as you can see, there's some steps here. Some steps skipped, rather. They've done some extra pieces of work that they didn't need to do, things that the order of operations take care of for us naturally. So in the first part here, as you can see, what we did is we flipped the order here by inverting the 16 and the 9. And of course I can do that by the commutative property, because again, the commutative property says I can change the order of the numbers and still get the same result. So I've got 21 plus 9 plus 16 now. Now, as you can see, the reason we did that is because now this is going to force me to do 21 plus 9 first. 21 plus 9 is going to go together to make 30. Anytime we can make a number that ends in 0, chances are it's going to be something that's easier to work with. And indeed, 30 plus 16 is a much simpler problem here. 30 plus 16 goes together to make 46. Final answer. Notice here they've justified here this step by simply saying adding. We didn't use one of the properties here. We just added up the numbers because there was really nothing else to do. What they've done up top, the parts we crossed out, is really unnecessary, and I think you see why. What they did here is instead of doing it the way we did it, they inverted the 16 and the 21. But if we used regular order of operations, I would still be doing that first because it's left to right. So then they have to insert parentheses to force you to do the 21 plus 9 first. And that's silly. It's not that it doesn't work. It works fine. It's just an extra step. We can do what they did by just doing the commutative property and using the order of operations that we've already come to know and love. Here's 20 times 9 times 5. Well, I don't want to do 20 times 9 because 20 times 9 is really, while it's not that difficult of a question, it doesn't leave me something easy to work with at the end. However, if I invert the 5 and the 9, or the 9 and the 5, notice now the problem says 20 times 5 times 9. And again, that was done with the commutative property. Now what they've done here, the line that's crossed out, is they've inserted parentheses to force you to do the 20 times 5 first. That's unnecessary because, as you know, multiplication is going to force us to go left to right anyway by the order of operations. So that's why we've crossed that line out. Well, now I have 20 times 5 in the front. That's 100. And of course, we know how easy it is to multiply by 100 because we just take the other number and multiply it and then add on 2 zeros. So I do the 1 times 9, which is 9, tag on the 2 zeros that are on the end of 100, and I end up with 900. Now they're asking us to use the distributive property to find 6 times 54. Now it's not that we couldn't do 6 times 54 by writing it out or with mental math. We could do 6 times 54 on a calculator, but there's an easier way to do 6 times 54, which is really what this section is all about. What they ask us to do here is to use the distributive property. And the distributive property is going to take that larger number, that 54, and break it up into pieces. And as you can see, what they've decided to do with 54 is rewrite it as 50 plus 4. And of course that would be the same thing because 50 plus 4 makes 54. So now what they've done is, instead of doing 6 times 54, they're going to take the 6 and multiply it by the 50, and the 6 and multiply it by the 4, and combine the results when we're done. And again, that's using the distributive property, which really was never in doubt because the directions told us we had to use the distributive property. When we show this, usually in a problem, especially when we throw variables in, as we talked about in the introduction, usually what we show here is multiplying the 6 through to the 50 and the 6 through to the 4 like that, and this sign in the middle, whatever it is, carries down into helping us find our solution. Well, we can do that because we've got 6 times 50 now. Well, of course, that means I'm going to do the 6 times the 5, and then since I've got the 0 on the end of 50, I'm going to tag a 0 on to the end of it. So 6 times 5 is 30, and then tag the 0 on, and I end up with 300. 6 times 4 on the other side, well, 6 times 4 gives me 24, and now I'm going to combine 300 and the number 24 to come up with my final result, 324, which is the solution to 6 times 54. Now that's not the only way to solve this problem. You could rewrite 54 in other ways. Now you could write it something like 52 plus 2, but multiplying 52 really isn't any better than multiplying by 54. What they're showing here is, instead of writing it with addition, they've decided to write it as subtraction. They've rewritten 54 as 60 minus 6, which of course equals 54, which is why it's the same thing. Now I'm going to do exactly what I did in the last problem, but instead, since there's subtraction in the middle, what I'm going to end up doing is subtracting those two results to come up with the solution. So I'm going to do 6 times 60 here. Well, that's pretty easy. 6 times 6 is 36. Tag on the 0 at the end, which is 360, what you see. And 6 times 6, which is 36, which is what you can see falling down the right side of the problem there. And again, because there's a subtraction sign in the middle here, I'm now going to solve this by subtracting these two numbers. And when I do 360 minus 36, lo and behold, I get 324, which is the exact same answer I got just a moment ago. So let's take a look at the concluding examples here in the Check It Out section. They're asking us in number 1 to tell which property is represented. They've got 5 plus 6 in parentheses plus 3 being equivalent to 5 plus 6 plus 3 in parentheses. Remember, your choices are what we saw in the definitions: commutative, associative, identity, and inverse. Well, what you see here is parentheses being moved. And a big chunk of parentheses being moved there is always indicative of the associative property. So indeed, this is the associative property of addition. Again, the associative property says I can group numbers together in a different way, but still get the same result. Now they're going to ask us to simplify a problem and solve it and justify our steps along the way. So we see 215 plus 73 plus 85. Now as that problem exists right now, that's not very friendly. I don't want to do 215 plus 73. It's not necessarily going to give me a number that's easy to work with. Realize we would have to do that first by order of operations. But if I flip the 73 and the 85 and instead write it as 85 plus 73 at the end, which is again the commutative property. The commutative property again states that I can flip the order of the numbers around and get an easier problem. Now I'm going to have to do 215 plus 85 first. Again, why? Because of order of operations. Well, 215 plus 85 makes 300. And that's really easy to work with because now it says plus 73. So I'm combining 300 and 73. Well, that's kind of a giveaway to the answer because 373 is 373. Solved much easier, no calculator, all mental math, thanks to the commutative property of addition. In the last question, they're asking us to use the distributive property to find 7 times 18 here. So remember, as we saw in the earlier example, the number you're multiplying by, the larger number, can be broken up in pretty much any way you want. So there's a couple different ways you can look at breaking up 18. Most of us are probably going to go the addition route and say 10 plus 8, which is what you see on the left side of the screen there to the left of the red OR. You can also break 18 up as 20 minus 2, which is what you see on the right of the screen there to the right of the red OR. Either way, the result is the same, so it doesn't matter which path you pick. But let's go ahead and follow down the path that involves addition, writing 18 as 10 plus 8. So now I'm supposed to take 7 and multiply it by 10, and take 7 and multiply it by 8, and combine those results. Well, 7 times 10, that's easy. That's 7 times 1, 7, and then tag on the 0 that appears there for 70. 7 times 8 is a number you could get right off the top of your head or from any simple times table. That's 56. When I combine 756, 700 plus 56 yields a result of 126, which is indeed what the value of 7 times 18 is. Again, you should spend your time focusing on how can I make a question easier? How can I do this problem without having to pick up a calculator? How can I make my brain strain the least to find the solution? That's what the properties of numbers and using the properties of numbers here is all about.